Today, let's look at sex-linked inheritance and practice problems that are associated with that. With sex-linked inheritance, we have inheritance that's happening on the X chromosome, and we have males. Remember, they have one X chromosome and one Y, and then females have two X chromosomes. A female who carries the recessive gene is called a carrier. She has the heterozygous genotype. She's healthy, considered normal, and doesn't have the disease, but can pass it on to her offspring. And so we call her a carrier, pass it on to her offspring. So whenever this is the case, because males have only one X chromosome and females have two X's, males more frequently have these disorders because they have only one X. So if it's a faulty X, shall we say, then they are definitely going to have the disorder. Now, I want to just go over the possible genotypes for females and males whenever we look at sex-linked inheritance, and go ahead and write these down. So the possible genotypes that we have X capital A, X capital A. This is an unaffected female that we would say is normal. We can have X capital A, X lowercase a, or the heterozygous female that would be the carrier, but would also be normal. Also would not be affected by this trait. So also we could call her unaffected, but she does have the trait for the disorder. So more frequently we call her a carrier female. If the female has X lowercase a, X lowercase a, then she would be an affected female. The only way that this can happen is that one of the X's had to have come from mom, one of the X's had to come from dad or the male parent, and so the father must have had the disease in order for this to happen. Now, if we look at the male genotypes can only be two. So we can have an X capital A, the unaffected male, or we have X lowercase a y, which would be the affected male. Keep in mind that the X is always coming from the mother, so always from the mother or the female parent. The Y is from the male parent. Okay, so let's do a few examples together. Let's take a look at this example for hemophilia. Hemophilia is an X-linked trait. It is a recessive disorder. And we're going to say that we have a female carrier for hemophilia. Her father had the disease, meaning that the father was X lowercase a y, so he would have passed it on to the female. And she marries a normal male. So what's the probability of them having a child that has the disease? So with this, we know that she is a carrier female. And we know that she marries a normal male, normal vision male. So the carrier female must have XX and the male must have XY. And so if we go ahead and we put in our alleles, we'll say that X capital A is normal, X lowercase a is hemophilia. So for the carrier female, she has one of each, so she'll be capital A, lowercase a, so X capital A, X lowercase a, and then the male has the dominant allele, so it would be X capital A, Y. So we'll go ahead and we'll do a Punnett square with these parents. So for our Punnett square, we're going to do them like we have in the past. I'll have the female parent over on the left-hand side, X capital A, X lowercase a, and then I'll put the male parent at the top, X capital A and Y. All right, I'm going to fill in the male parent. So male parent gives X capital A and gives Y, and then the female parent gives X capital A, X lowercase a, and X lowercase a, Y. I'm going to switch this around just for convention's sake and just have X lowercase a. It really doesn't matter, but it just is easier to see, I think. All right, so let's keep in mind whenever we're analyzing the offspring, how many of the offspring will be female? So keep this in mind, 50% of the offspring will be female, 50% of the offspring will be male. All right, now if we were looking for how many will be affected by this, so our only affected offspring will be these ones, okay? And so we have a 25% chance of affected offspring. We also have all of the females will be normal. So if we're looking at the females, if we're looking at the females, they'll all be normal, and the male will also be normal. Okay, so 75% chance normal offspring. Keep in mind that 25% of the females will be carriers. So this one down here, she's a carrier, meaning that then she's heterozygous for the trait and could potentially pass it on to her offspring. All right, so let's go ahead and take a look at another example. This time we're going to look at the examples that you have written down. We're going to look at fruit flies, and we are going to look at the eye color trait, which is an X-linked trait. So the wild type or the normal eye color is red, so X capital R is red, and then X lowercase r is white eyes. So this first problem says, what are the probable genotypes of both parents when you cross a red-eyed male with a red-eyed female, and then it gives the resulting offspring. So for the parent, we know that we have a red-eye male, and we know that we have a red-eye female. So the male has to have XY, the female has to have XX. In terms of the alleles, the red-eyed male, we know then that he has to have the dominant allele for this trait. And then the red-eyed female, we know that she has to have at least one dominant allele, and then we're not sure yet about the other one. So if we look then at the offspring are that she has 19 red-eye females, 11 red-eye males, and 10 white-eye males. So take a minute and write down what are the genotypes then of each of the offspring. So your genotypes for the offspring, the female, you know she has to have one dominant allele for the offspring. Red-eyed males, X capital RY. White-eyed males, X lowercase ry. So let's take a look then at what we can gather from this. We're just missing one of the alleles from the red-eyed female. Let's take a look at the male offspring. Keep in mind that whenever we are looking at the offspring, the Y that the male offspring had to come from the male parent. So the male parent gave the Ys. There's no other way to get it. What that means then is that the female parent is responsible for the Rs. So the Rs, or the X's, come from the female parent. So because of this, we can see that the female has X capital R, so that comes from the red-eye female, but also X lowercase r, so that also had to come from the female. So the female would be X capital R, X lowercase r, she would be a carrier, and this would be the genotypes of the parents in this example. Let's go ahead and take a look at example 2. So we're still looking at fruit flies. And we have X capital R is red eyes, and X lowercase r is white eyes. In this example, we're looking what are the probable genotypes of the parents. So we want to know the genotypes of the parents. When we get the following offspring. So the offspring that we get, we have 10 red-eye males, we have 9 white-eye males, we have 9 red-eye females, and we have 8 white-eye females. So go ahead and write down what are the genotypes for each of the offspring. All right, so you should have these genotypes written down for the offspring: X capital RY, X lowercase ry, X and then at least one capital R, and then X two lowercase r's for the white-eye female. We know that we have a male parent and a female parent, so X and Y, and then X and X. Let's go ahead and start with the female parent first. So again, if we're looking at the male offspring, so let's look at the male offspring first, the Y always has to come from the father or the male parent. So male parent is here, female parent is here. So the Y always has to come from the male parent. Keep this in mind. And that means that the X has to come from the female parent. So X capital R, X lowercase r, both of these have to come from the female parent. So this means that if we're looking here, X capital R, that came from the female, so we know that she has a capital R. X lowercase r, we know that she also has a lowercase r. Now, we need to figure out the male parent genotype. So for the females, what we want to remember is that one X comes from each parent. Now, the red-eyed females don't necessarily tell us anything, but if we look at the white-eyed females, so if we're looking here at the white-eyed females, we know that one has to come from each parent. So we know that one has to come from the female parent, and we know that one has to come from the male parent. So the way that this works, again, female parent, okay, X lowercase r, we already know that. The other parent then must have given the female the X lowercase r, so in this case, the male parent would be white-eyed, X lowercase ry, and then the female parent is X capital R, X lowercase r. So go ahead and give the other problems a try. Let me know if you have any questions related to sex-linked inheritance.